Now for part C. In this video, I'm only going to use one method, and I'll use L'Hopital's method in my next video. So there'll be two videos for part C. Now we want the limit as n tends to infinity of 1 minus 2n divided by the square root of 3n plus 4. And if we substitute infinity straight away, let's see what we get. We would get 1 minus infinity, which would probably tend to negative infinity. 1 minus a really large number would be a really small number. It's negative infinity. And the square root of a really large number is a really large number. So we will get negative infinity divided by infinity. And please note that the infinities don't cancel out to give us negative 1, in case you were wondering. Alright, so let's see how we would go about doing this. The limit as n tends to infinity, and I'm not going to straight away divide by the highest power of n, because that may lead to a bit of a problem because of the square root. So this is what we're going to do. I'm going to rewrite my numerator as the square root of 1 minus 2n all squared. And what's the square root of 1 minus 2n all squared? Well, it's 1 minus 2n. So we haven't changed our numerator, and my denominator remains the same. We now have the limit as n tends to infinity, and we should know that square root of a divided by the square root of b is equal to the square root of a divided by b. So we're going to use this to give us one square root. Removing my brackets, I would get 1 minus 4n plus 4n squared divided by 3n plus 4, which I will now write as the limit as n tends to infinity of 1 minus 4n plus 4n squared divided by 3n plus 4 all to the power 1/2, which is square root. Now I'm going to divide throughout by the highest power of n, which is n squared, or squared. We get the limit as n tends to infinity of 1 over n squared minus 4n over n squared plus 4n squared over n squared divided by 3n over n squared plus 4 over n squared all to the power 1/2. Let's tidy that up a bit. We get 1 on n squared minus 4 on n plus 4 divided by 3 on n plus 4 on n squared to the power 1/2. And we can now evaluate this. 1 on n squared, that's going to tend to 0 as n tends to infinity. So will 4 on n. 4 will be left as 4. 3 on n will tend to 0. 4 on n squared will tend to 0. So what do we get? We get 4 divided by 0 to the power 1/2. And we know that we cannot divide by 0. So this is undefined. There is no limit. And since there is no limit, our sequence un is divergent. So we have a divergent sequence. And there we have it. And you see, this took a little manipulation because of the square root. But once we can get past that, it's the same principle of dividing throughout by the highest power of n. And we have division by 0, and our numerator is not 0. So this is undefined. So our sequence since it isn't convergent. It doesn't converge to any specific value. It is divergent. Thank you for watching this tutorial, and I hope that you found it helpful.